Thanks for joining me today. We're going to talk about Layer 7 behavioral DoS on F5's Advanced Web Application Firewall. This solution is really cool because what it's doing is dynamically building a signature as it's needed to mitigate DoS attacks. So the first thing that it does is it baselines what does normal traffic look like, and that's not just the volume of traffic, but that's different factors about the traffic, like maybe how many headers are normal and what headers are normal, just as a couple of examples. So it's going to figure out what's normal, and it's going to figure out what normal stress on the server looks like, what is typical response times and latency and things like that. When it detects that there's stress on the server, it's going to start mitigating that stress by rate limiting the traffic and then identifying the anomalous traffic based on its prior knowledge about what's normal, and then build a dynamic signature to stop that traffic. It'll begin by rate limiting, and then we can even move forward to blocking it entirely, as well as moving that into IP-based blocking by identifying them as bad actors. So we're going to jump in now and see how that's configured. Okay. What you can see here is a web application deployed behind an F5 big IP. We've got traffic moving through it right now and no protections deployed. So this just has active traffic. We're going to go ahead and deploy behavioral DoS. So we'll come down here to DoS protection, DoS profiles. We're going to create a DoS profile. We're going to click on it. We can set up whitelists here if we need to. We're going to go to Application Security, and we're going to turn that on. We're going to go down to TPS-based detection. You could use this in production to protect at a high level. You say, absolutely don't go above this level, for instance. But we're going to do only stress-based deployment in this case. And bot signatures are also commonly suggested for a production deployment. So we'll go to Behavioral, and we'll go ahead and turn that on, Behavioral and Stress-based. So again, this is based on the stress of the server. We'll leave the regular stress-based turned off and just use the behavioral detection and mitigation. So we're going to turn on bad actors behavior detection. So that's after we identify the sources of the bad traffic. We can add them to a list and start blocking them that way as a source of bad traffic instead of just by the signature. And then this actually turns on that dynamic signature capability that we talked about. We'll show approving the signatures in a little bit. So if we do this, then it will not automatically activate mitigation with that signature. It'll wait for us to manually approve it. If we leave this off, then it's a fully automatic process. Mitigation is conservative, standard, or aggressive. Conservative says only block traffic that we know is bad. Standard says only block traffic we know is bad unless that's not enough and the stress on the server is still too high. Then during an attack, go ahead and rate limit all traffic. And aggressive says always rate limit if we need to keep the server health in a good position. So usually you want to go with standard protection. So we're going to implement that, and we'll hit update. Then we'll go down here to event logs. We need to set up a logging profile so that we can collect data on it. DoS protection will enable a local publisher. You could publish to a remote publisher if you wanted as well. And now we'll go add those onto the virtual server to add the protections. So we'll go to Security, Policies. On the virtual server, we'll go to DoS protection, enabled, behavioral DoS. Select the log profile, the one that we made. And now we have protections in place. So what we're looking at here is I've run this CLI command in order to determine what's the learning status on that baselined normal traffic. So this third value here is how many samples are we currently considering, and then this second value is how many buckets of information are we considering in our view of the traffic, and then this is what's our confidence level on our understanding of that traffic. So this is getting pretty high now. We have a pretty high confidence. It hasn't been too long looking at the traffic coming through. We're now going to take a look at Grafana in order to get good visual representation of a lot of data about this. So all the data on the big IP is able to be accessed through third-party tools as well. So here's Grafana. Grafana tells us we're in peacetime, we're not under attack. It tells us that there's good health on the server, so we can see the line down here is in the green. We can see that it's figured out what's a good baseline for the number of HTTP transactions per second and what's the current traffic like, as well as the server-side connections. Up here, flashing, we've got the threshold learning at 92%, so that's really good, on 15,600 samples. So it's about time to launch an attack and see how it responds. Down here will be the mitigations. So we can see we've just launched an attack. Grafana shows us that it's identified it's under attack. Again, this is data coming directly from the big IP. We can see that there's a huge spike in HTTP transactions per second and a big spike in server-side connections on the backside of the big IP. The health of the server has gotten much, much worse, and we can see it's here in the red. But now it's beginning to improve. We can see that the server queue, this is, how long are we waiting? Here we've got the concurrent server-side connections have dropped down. So why is that? What's going on here? We can see that we've got mitigations going on. So initially we have rate limiting happening with all the IPs coming in because that's what we set up with standard mode. But then we're moving to signature-based detection. That's the purple here. And soon we'll move to bad actor rate limiting. So we'll be blocking them based on identifying that they're bad actors. And we could even take it to the next step and do full layer 3 blocking of the IP address instead of just rate limiting of that IP address. If we look at these identifiers, we can see this is when the attack started. This is when we've got a stable signature developed. So that's those dynamic signatures based on a number of values. So we can see here are some of the values that we're looking at. Okay, so we can see that a couple seconds later now, we're actually beginning to block by bad actor IP. So you can see that the method of blocking the traffic has changed. So we no longer are in need of the signature. We can see that we're blocking all of it by bad actor IP. We've identified all of them. So this gives us a pretty good idea of how the attack started, how we protected the server, and then how we mitigated it over time as we learned more about the traffic and developed not one but two signatures in order to block that traffic. So let's take a look at what one of those signatures looks like and what the visibility looks like on the big IP now. So here we can see that we've got a DoS attack. It's shown on the graph here in the big IP. We can go to the DoS summary and we can load the DoS visibility dashboard. So we'll see here that we've got an attack detected, and we could start drilling into that one. And you can see here that when we select something on the right-hand side, what it does is it immediately drills down and narrows what's in the display part of the screen to only that data. So we could say, well, let's narrow it and only look at this virtual server, the web app. It already was in this case because we only had one. We could open up the mitigations and we could say what kind of mitigations are being done. We can see it's all behavioral mitigations. Where's the traffic coming from? All over. So we can get a lot of good data here and we can drill into it to see exactly what does the attack look like, when did it start and stop, and what did we do about it. Next, we might want to look at the bad actor IP detection. So here we can see a list of the IP addresses that we're rate limiting, and we're rate limiting 80% of their traffic away. So we're only allowing a small chunk through. We can see the timeout on that. So when that gets down to 0, we'll see are they still a bad actor, and if so, we'll continue blocking them as they near that, and we'll reset it. Next, during an attack, we might want to look at what does that signature actually look like. So here's one of the signatures. We can see that here are the different values that we've identified are anomalous about this particular value. For instance, the HTTP referrer hashes are 51, the headers count is 11, and so on. So when all of these are true, we know that this is bad traffic. So we can look over here. We can get some data on this and we can decide whether it's approved or not. Again, we're set up in automatic mode, so we don't need it to be approved. But we could also check the box and we could make it persistent, and that would move it down here to the bottom, which would enable us to use this later on if we wanted to keep it and not just make it a dynamic one. We could also make this a shareable one, which would mean that if there were multiple virtual servers, this could be used across them instead of only on the one. And last, we can create our own persistent signature by adding one here and building it. So we're going to end back here at Grafana. We're going to take a look. We're still under attack. We have a good health score here, and down here you can see that we had to adjust from blocking by bad actors to blocking by signatures again and develop more signatures, and then begin blocking those new bad actors. As the attack changed, so did the defenses. You can see that we had a spike in the server queue, but the server health is still good. We're still responding properly to requests, so the user experience is still what we expect. So this is going to dynamically change with the attack, hands off, without us touching. And that's what we're looking for in a DoS solution. So thanks for joining me today. That's Layer 7 Behavioral DoS on F5's Advanced Web Application Firewall.